My name is Dr. B. Srinivas, Department of Mechanical Engineering. Today we are going to discuss about the wire EDM. Okay, so how the wire EDM is carried out. Let's we discuss. So the very basic point already we discussed previous also the electro discharge of a machining here. Now once again we are discussing about the advanced means of a wire uh, EDM here. Okay. So the previously just we recollect of that one. How can we take place of a EDM here? We know that one is a thermal conductivity we are using on the this one of a EDM electrical discharge due to ionizing. Okay, means by using of a cathode which is connected to the electrode, and the positive is connected to the anode is connected to the workpiece here. Same things take place here by vertical way conducting we are using of a wire EDM here. So now see here from the wire EDM here, see from the diagram. Okay, now the wire EDM here, the very basic point of wire EDM is we are using of a wire and EDM here. So wire, if I take of a wire, means here it should be a thermal conductivity here. A very basic point. Okay. Now it may be using of a wire. This type of a wire which is a thermal conductivity. It may be a brass. Okay. The wire which we are using here is it may be a brass, it may be a copper, or it may be a tungsten here. Okay. See which is connected with the roller here. Okay. See which is connected with the roller. Okay. We are just making of a passing of this of a wire of a against of this workpiece here. Okay. This wire is connected with of a cathode, and this is with a anode here. Okay. So very basic point means we are going for the thin wire, okay, which is a thermal conductivity should be there here. So due to that one, what happened? Ionizing can be taken place here. So that is the reason we are going for the for ionizing. We are going for the thermal conductivity of a material of a wire here. So that may be a brass, it may be a copper, or it may be a tungsten here. Okay, and we know that the dielectric of a supply here. If I'm saying of a dielectric of a supply, previously we also known that one of a for EDM also we have a hydrocarbon and the mineral oil we are using for the dielectric of a future. In the same manner we are also using here also the same way. And the okay, and the workpiece also it may be a thermal conductivity because it's everything will be taken place in a dielectric field. Okay. So here after this one we are supplying of a means of a wire diameter here. What is the spark gap and the slot of a curve. That's we discuss about. Okay. So what is the basic concept of our of a wire EDM? First thing, it is a unconventional of a machining process here. Okay, we are using some form of energy, that is a discharging. By using of electricity, we are discharging that one. Means ionizing can be taken place here. So in that way, we are removing the material. Okay. If I say of a example, simple of a example of a working principle is it is a deals with the electrothermal. Means here electric and the heat is taken place here. Electrothermal means here electric electro is electricity and the thermal is a heat here. Okay. So here means of electric, if I'm saying of electric means what happened, there will be a spark is generated with this of a wire here. Okay. Spark is generated from this wire here. Okay. Which is a thermal conductivity. It may be a brass, copper, it may be tungsten here. So what happens, the spark and the heat, then the electrothermal conductivity can be taken place here. Okay. If I am using of a dielectric of a fuel, of a dielectric of a supply, means here first thing, what is the meaning of deionizing? Means there is a no ionizing can be taken. Means there is a no ion can be break here. After that, then will be a, when a voltage is a means of a with a high potential is taken place here, then it's converted into ionized here. Okay. Yeah, basic point already we have discussed. So at what degree here? Means here we are means we are heating of a up to 8,000 degrees. Okay, we are heating of 8,000 degrees to 12,000 degrees Celsius. We are heating that one. Okay, 12,000 degrees Celsius we are heating that one. So that what happened here? Then the melt of a vaporization can be carried out here. Okay. And the very important, we have to know what is the wire diameter. First, we have to know means there will be a very important point is the wire diameter here. Then only we can go with the spark gap. Okay, if I'm saying of a wire diameter, we can use of a 0.25 mm of a diameter. We can use of a wire diameter. Okay, we can use of a wire diameter. We can use of a 0.25 mm. We can use here. Even we can go with the curve. Means plot of a we can go with the means plot of a curve of a width we can also go with that. Means we are maintaining of a 0.41 mm here. Okay. If I am saying of a this both thing, if I know that one means of a wire diameter I know and how much of a slot I have to go with that one, then we can go with the spark gap. That is the formula is there. Okay. The spark gap is equal to, if I say of a spark means what happened, there is a curve with and minus of a wire diameter divided by 2, that is a spark gap. Okay, that is a spark gap. And we can also say that here we can go with the cut of a 300 mm, can be a thick, can be a cut, 300 of a mm can be a cut, even with the small inches like of a, we can go with a point 0.004 inch can also be a cut. That is the beauty of this wire EDM. And we are going with the CNC of a machining process here. Okay, let's go with the introduction part of it. So here with the from the introduction part of a wire EDM here is a, see from the diagram. Okay, is a very clear no. So once again I am going with this one. See here. So we are using of a here of a wire we can go with the brass, copper, we can go with the tungsten here, and with this with the roller or a reel we can also say here this is the wire guide. Okay, when there will be a con means there will be a come near to this workpiece, so with a spark of a gap here, so what happens, there will be a ionizing, can be a spark is generated here due to ionizing, due to of a thermal conductivity, because this everything can be placed in a dielectric of a fluid here. So dielectric of a fluid we are using as a hydrocarbon, or we can use of a mineral oil also we can use here. So both are of a workpiece as well as of a wire. We are using of a thermal conductivity, and this is going with the help of a CNC of a machining computer numerical control here, because of a different types of a directions we are using of this one. Okay, and this wire is a contact means of a near making of a near to this workpiece. There will be a machining operation can be carried out here. That is the beauty of this one. Okay, now we are going with the introduction part here. So if I saying this is a wire EDM means electric discharge of a machining. We already known that one. This is a part of a electro discharge machining or electric discharge machining here. So in that one, this one we are using for the vertical of a electro discharge machining. We are going with the wire EDM. Vertical position of the electro discharge machining or electrical discharge vertical position, that we are going with the wire EDM. Okay. So here the production means of a thin single of a strands of a wire here along with the deionized of a water here used to conduct the electricity here. Wire to cut of a metal by use of a heat from the electrical of a spark, just now I said, while preventing of a rust. In the same manner, what happened, of a material can be cut using of a wire EDM, just now I said, due to of a ionizing here. So what happened, there will be a means of a converting of a voltage of a into a potential wave. So the ionizing can be taken place here. Electrons will be generated here. So atoms, due to that one, there will be a material removal can be occur here due to that spark here. Okay, and this would be all metal can be including of a steel, aluminum, brass, titanium alloys, or the super alloys of all types can be carried out. Okay. Now this is a difference. So here the if I say of a difference here, so between of a wire EDM to the conventional means there is a two main difference are there here. Okay, convention of a stringing wire or a wire cut or a convention of a EDM. If I say of a here, there will be a means what happened. There will be electric of a current is there. Means the tool and the tool I said of a tool is a cathode here. Terms of a means of a electrode we can say that is connected with the cathode in a previous of a already slided of discussed with this one. Okay, hence along of a metal of a piece here, anode workpiece is connected with the anode, with due to of a what happens, there will be a contact with this one, there will be ionizing can be taken place here. And electric current is a react to melt and the vaporize of a metals here. That is the ionizing can be carried out. Okay. So this is a dielectric of a fluid or a hydrocarbon. Just now I said of a, it may be a last class also I said of a fluid will be a dielectric of it may be hydrocarbon of oil or maybe mineral oil, and the both the cathode and the workpiece are submerged, and the minute of a chips is produced by the of a process is means wash away from the workpiece also. And here the wire EDM, wire cut of an EDM, and we can say the wire cut electro discharge of a machining are a electrified of a current by means of a thin of a wire here, that is a cathode. Okay, and it will make of a cutting path, or we can say that is a slot here. Okay, so in this manner we are going to difference of this one here, and history that is from the EDM, it comes of a wire EDM. And it is a EDM. We already know that when it is started in the Second World War here from the two Russian of a physics of a BR and NL of a Lazarniko, and published the studies of a inversion of the electric discharge of a wear of a affected due to that one it is come here. Okay, which is application to the manufacturing of a technology of a electric of a discharge here, and to remove the material here. And we know that one of a EDM also used at the time of remove a broken of a taps and the drills also sometimes. What happened? We know that when tap lots of a rust and it will be broke here, we can cut that one. Okay, we can go with this type of a process here. Okay, and here also the hand free of electrode and burning of a hole in the center of a taps here also, and the remaining a fragment of a tap can be picked up. The same manner, and we know that on this the electrical so very expensive of a beam and having a made over again. Okay, so in this manner we are, this is the history of this one here. So once again we are going for the C here. So what happened, there will be a spark is generated. We know that when the ionizing can be taken place of electrons and the atoms here, and the feeding of this one of a wire here, and the tool holder which can hold this one of a dielectric fluid, we can use of a hydrocarbon, or we can use of a mineral oil. And here the of a some of we are pumping of a nothing but a, here we can also go with the this one of a dielectric of a fluid here, and a fixture which can hold this workpiece here, and for anode I said of a, it is a connected with the anode which is connected to the workpiece here, and the cathode is connected to the tool holder here, and DC supply of a generator can be taken place here. See, this one is the positive terminal here, and here negative terminal. Okay, cathode and the anode here. So here in this manner, this also be a wire EDM is a vertical. Just now I said of it is a vertical of EDM of a kid of a brother here, and it is not a new kid of the block. We can also say here, and we know that one of wire EDM is also introduced in a of a late of a 1960 here, and revolution of the tool and the die of a mold here, and that is a main of a mainly of a metal working of industries here. And even we can go with the last 50s of years of a numerous advantages to be offered here, and mainly in the develop of a industries here. Okay, it can be carried out in a industries especially here. And we know that one of a machining of a that electrically of a conductivity of a here for the more, and we can go with the steel, aluminum, copper, graphite, tungsten, and exhaust of a space of a areas also. And we can also titanium iodide of a carbide of a polyester of a diamond copper and the conductivity of it, whatever it may be, that it may be having a thermal conductivity. We can go with this type of a machining operation by using of a wire EDM also. See from the diagram just now we have discussed about this one, and the machine see here the wire EDM are manufacturing various size here. Okay, means we are knowing that one. This is a here. Okay, means of a various styles, size, styles, and the flush and the submerged of a types of a machines to fit the need of a customers here. And we are using of a the EDM for can handle the workpiece of a weight, and over the 10,000 of a pounds can cut the over a 20 inches of a thickness. We can go with that one. And we know that it is a automatic of a wire of EDM here. So it is a what happens, we are using of a CNC, computer numerical of a control in this way, and which can go with the using of a CNC of a machining here. So we can direction of a control of a tables of any direction. It may be XY direction, and the rays means of a travels means of a ultraviolet of a rays is the travels means electrons is generated here. So the electrons what happen atoms are got here. So there will be electrons on the atom. So what happens there will be having a ionizing can be taken place here. Okay. So here we can go with any different types of a means it may be a taper cut of it, maybe degrees of a workpiece of a thickness can also be a category. Okay. This is the machine and the mechanical of a section is means we can also go with the work table, work stand, taper unit, wire, drive mechanism. That is also very important thing of is a body here. Dielectric of a system. We know that when mineral oil or we can go with the uh, hydrocarbon here, which is which is also a thermal of a resistance here. So what happened here? And there will be having of a water to be in a maintained here and thin office of a no cement here. So here we can go with this of a the principle of a wire of a here principle of this of a wire EDM here means here we are going with the basically of a same of a concept of a EDM electro discharge of a machining electrical discharge or we can say electrical discharge machining process same. Only the thing is we are going with the vertical position here. That's only the difference of a from the EDM to the wire EDM here. Okay, and we know that one that is the thermal conductivity of a machines here. Just now I said of a here, it may be a thermal of a series of electrical of a discharge here, spark that are produces between the means of a here, the moving part electrodes and the workpiece here. In the same manner, there will be a having a altered or a direct current. We know the DC supplier is there of a and the workpiece is a very small spark and can be insulated of a dielectric of fluid. That is a water. We know that an insulator we can use with the water. Sometimes we can use because more it may be take place of it. So they will be having an insulator. Okay, they are using that is a water here, and the heat to be a electric of a spark of a means of a estimated of around of it. Just my side of it maybe 8,000 to 12,000. It may be what happened. It may be we can also use of a 1,500, 15,000 or to a 21,000 of a Fahrenheit of a erodes of a bit of a material that is a vaporize of a metals from the workpiece also. But sometimes we are using of heating of a 8,000 to 12,000, or we can go with the 15,000 to 21,000 Fahrenheit here. In the same matter, what happens, there will be when there will be a machining operation. So there will be having a chips are flushed away and the cut with a deionizing of a water through the top and the flushing of a nozzle. We know that after that there will be having every all time we can't go with the ionizing. So there will be deionizing can be taken place here so that there will be no physical passes should be carried out here. Then the flushing of the whatever the material is removed from that one, it is flushed out. That is the beauty of this one here. Okay. And the computer numerical control, just now I said of a the means of a numerical is produced with the needs of operators in mind. So in which way we have to go in X, Y directions here. Okay. So it may be having a program of a machine coordinator and the cutting speeds. What are the speeds where whatever maintained we have to this spark gap should be maintained. What are the thickness we have to maintain? What is the curve of a slot can be taken? Curve of slot can be take place here. That everything is by using of a computer numerical control. That is the beauty of this one here. And we can go with the directions of a all directions here, and is a capable of a scaling of a and a mirror of a imaging of a rotational of a axis exchange of a year, and with a entire family of a part from the single program without of a need of a edit of a program here. Once we have made this one, no need of a every time. Once it may be having a single program without of a bit of the program can be also be carried out here, and we can say of a mirror image is a gator of a left and right handed of a parts here, and there is a shrink of a factors of a plastic cavity of a or extrusion of a dice. We can go so 90% we are going for the tools, and the dice also process can be carried out by using because there is a very good surface finishing can also be occurred here due to the spark. Okay, to the erosion means of a whatever there is spark is generated. So in that way we can go with the smooth surface finishing also be carried out here. In the same manner, they will be having a uh, operator with the setting of a job there by using of a CNC of a control machining here, and we can also go with the goes with the future of a control handle is offset here, and the very important part is a tool is a we are using is a wire here. So the tool we are using as a here is a instead of a electrode we are using of a here is a wire here, that is a copper, it may be a brass or it may be a tungsten here. Okay, just now I said of a we can use of a diameter with small to small 0.00 4. We can go with the diameter of a width can be cut here, and we can go with the point of a slot 0.004 also. I said of a 0.012 of a slot can be a power setting, can be a particular material, and the diameter and the slot of a cup we can also say. And the when we can saying of a how the gap can be a, means we have to say means the wire diameter minus of a gulf of a slot. Okay, the slump of a short minus of a diameter by divided by 2, that is a spark gap. The spark gap can be, we have to maintain that formula can be occurred here. Okay, so from that one we are going for this one here. See here, uh, when the wire EDM of a machine is first introduced in the netted set, we know that one. Okay, so here we can go with the supply. What is the power supply can be taken? Means here means equipped with a power supply is that can, that would be achieve a less than of a 1 square of an inch per, means we are using a very less power here. And here the that is a depend means for less power also we can go with the more faster here also. That is a very important point here, is that is a depend upon the wire diameter and the type of a wire which we are using on that one, and what is the position of the nozzle here. This everything with a less power also we can go with the with a good surface finishing and the accuracy. Okay, after the machining process also, that's the beauty of this one here. See here how it can be taken place here, means of a uh, adaptive control is a another improvement where the high speed of a security can means of a security of a spark is gap is, means if from this diagram. Okay, we can say here the how the spark is generated here. See this one, how the spark is got generated here. Okay, means we are saying of a here, uh, see here, means of a spark of a sensitive reaction time of a serve of a motor of a changes here. And here the wire of a breakage is reduced to minimum of a making of a today's machining for and for giving than in the past also here. Okay, in this way the spark, how the spark is generated here. See, this is the previous is this one, the for the making of this one, how the spark got generated here. Okay, now if I say of a wire path here, see here the wire path we should, so the wire path if I'm saying here is means the we know that a wire, it may be a copper wire, we can use of a brass or tungsten, we can use of it because it is a conductive. Very important point just now also there will be a very important point is that there will be a thermal conductivity should be there here. That is a depends upon the thermal electrothermal here, the spark and the heat that we are going for the machining operation here. And the limitation were soon of discovered here. And the low tensile strength of a copper wire here is subjected to a wire breaking can also be too much of a, sometimes it may be having a wire breakage can be taken place due to of a tension was applied here. And a poor of a flushability with another problem also can be occurred due to a copper of a high thermal conductivity also can be carried out here. So in this manner we are going for the wire diameter of a, means we are maintaining of a range. Just now I said a wire diameter 0.004 inches to the 0.14, and the we're using of a wire diameter here. Wire because the wire plays of a major role here, because with that one only spark is got generated here. With the spark generated, what happened, there will be ionizing can be occurred here, and from that one there will be having a material removal rate can be take place here. Machining operation can be carried out here. So here the wire is a very important point, very basic point is this one, that we are using of a copper wire, it may be a brass or it may be having a tungsten. That is a see we are saying of a wire EDM. Okay, wire with the help of a wire we are using, we are going for the electro discharge of electrical discharge of a machining is carried out here. Okay, so the wire then of a passes through a set of precision we can, so that is the we are saying of a good accuracy here, precision, and of a diameter of a guidance here, and the transportative waste of a bin here. And we can also can be used once in a and should be routed with the EDM of a process. One is the use cannot be used on one side another. Okay. So dielectric, if I'm saying of a dielectric of a systems, we are saying of a, just now I said of a dielectric of a system, means we are using of a dielectric of a fluid, we are using of a hydrocarbon, we can use that one, or mineral oil we can use here. So very important what is the what EDM vertical, if you are using of a EDM concept only in vertical way, That is we are using for the wire EDM here. And the dielectric system just now of a water reserve means here we are going for the water for the reserve means for water the basic point we are using for that deionizing that one, okay, for flushing of that one, okay, and filtering system, and the deionizing is a system, and the water chiller of a unit we can use that one. And we can also go with the unfiltered of a system or side of the dielectric of a reserve where the water is then pumped and the filter through a paper filter also. We can go with that one, and the clean side of a dielectric of a tank can be carried out here. Okay. So here we can say here now the application is the last point of the hobbies. Application here is here. So the very important point, we know that one already we have discussed the advantage and the disadvantage and the applications also here. Now for the wire EDM is a very important point is a small holes of a drill of a electrode. See this one, the small holes of a drilling of electrodes and can be carried out here, and hardness of a steels. It may be any type, it may be hard, it may be a brittle, that is depend upon that material here. But we should be a material should be of a conductivity here. That is a if you're using of a conductivity, it may be it doesn't matter of it may be a uh, it may be having a brittle or it may be ductile, but it may be having a thermal conductivity should be there because it takes place in a path. Okay, that is a dielectric of a fluid here. Both the electro wire as well as of a workpiece should be a thermal conductivity. Then only the ionizing can be carried out here, and the machining of material removal can be occurred here. That is the unconventional machining process. We are using some form of energy here. In this way, we are going for the very small of a piece here, and the ideal of a choice. We can also go with the of a too delicate of a other of a machining operations. We can due to of this one. We can go with the brittle material also. Even with the copper, brass, and the other of a material of a miles of a, along with the adding of a cost to the copper process here, we can does not cause of a burst here, and means of a an event of a surface can be formed here, and thermal stress is certainly of a present here. So here this is a so now the we can go with the recollection of our topic here is see here. So we can once again for the recollecting of our topic is our from the diagram here. See here from the diagram once again I am recollecting that. Okay, here we are using of a see here the wire which we are using of a wire we are using of a copper wire. We can go with the brass or we can go with the tungsten. It can be feeded, the wire can be feeded by this reel, we can say this reel, okay, and which is also should be a guide of a wire guidance should be taken place. When this wire, it may be copper, tungsten, or it may be a brass, when this is near to this workpiece, this is take place in a path. So what happens, there will be a workpiece is also a thermal conductivity of a material. It may be it doesn't matter of it may be a brittle material, it may be a ductile of a material here, but it should be a thermal conductivity of a material due to of this dielectric of a fluid here. By using of a dielectric of a fluid, we are going means we are using of a hydrocarbon, or we can go with the mineral oil here. So what happened when we are making near, we are just moving of this wire near to this workpiece here. So that can be a means spark got generated here due to of a ionizing here. So there will be a due to of a dielectric of a fluid here. Okay, when this can be carried out here, okay, so there will be a removal of material can be occurred here due to electrothermal process here. Due to spark and the heat, the removing of a excess of a material from the workpiece to get a desired size on the shape. Machining material we can say over here. Okay, machining of a material can be taken place here. So we have to maintain means we have to maintain the what is the diameter of the wire as well as how much we have to go with the cut slot can be taken place. That can be maintained means there will be having a gap. Okay, spark gap should be there. You go near to that one, the wire gets of a broke here. So if you go away from that workpiece here, there will be means of a spark get generated very less here. So there will be a spark gap can be a getting of a by using of a formula. Okay, as a wire diameter minus of a curve. Okay, by divided by the two. That is a spark of a gap can be known. Okay. So after that they will be having. Okay, this is a very simple process of knowing of a wire Okay, EDM. Thank you and have a nice day.